Greetings, dear friends! On October 22, 2008, India launched the Chandrayaan-3 mission, a momentous event that would capture the attention of the world. This spacecraft successfully reached the moon and made a discovery that would make headlines globally. Water on the moon. Chandrayaan-3 provided robust evidence for the existence of water on the moon, marking a significant breakthrough. To be more specific, this water was found in the South Pole region of the moon. Following this groundbreaking news, countries worldwide reignited their fervor for lunar exploration. The United States and China initiated regular missions to the moon, while Israel embarked on a mission aimed at achieving a soft landing. Furthermore, Japan, Europe, and Russia had ambitious lunar missions in their plans. However, today, the world's attention is firmly fixed on India's Chandrayaan-3 mission. What groundbreaking discoveries might Chandrayaan-3 uncover? And what were the reasons behind the failure of the Chandrayaan-2 mission? These questions will be addressed in this video. India is once again on a journey to the moon, marking a historic mission and the launch of India's Chandrayaan-3 spacecraft. India is already making strides toward the moon, with the Chandrayaan-3 mission aiming to touch down on the largely unexplored South Pole of the moon. Moon missions, which encompass various types of missions sent to explore the moon, have evolved significantly since their inception in the 1950s. As technology has advanced, these missions have become more intricate. The simplest type of mission is the flyby mission, where a spacecraft is launched into space and passes by the moon without entering its orbit. The first successful flyby mission was conducted by the Soviet Union in January 1959 with the spacecraft Lunar 1. 2 months later, in March 1959, the United States achieved its first successful flyby mission with Pioneer 4. These missions aimed to study the moon from a distance. In October 1959, the Soviet Union launched Lunar 3, providing humanity with the first close-up photograph of the moon's far side, a perspective seldom seen from Earth. Today, flyby missions are typically performed when the moon is on the path of another mission. When a more detailed examination of the moon is required, orbiter missions come into play. In these missions, spacecraft approach the moon and enter lunar orbit, allowing them to study the moon's surface and atmosphere. Over 40 successful orbiter missions have been conducted to date, making this the most common type of lunar mission. The first successful orbiter mission, once again, was achieved by the Soviet Union with Lunar 10 in 1966. Following orbiter missions, there are impact missions, which are essentially extensions of orbiter missions. In this phase of the mission, the primary spacecraft continues to orbit the moon, while a segment of the spacecraft becomes detached and performs a controlled crash landing on the lunar surface. This specific type of mission is termed an impact mission. You might wonder about the purpose of such crash landings. The answer is rather straightforward. During the descent and impact, valuable instrument readings can be collected as the spacecraft approaches the moon's surface. This is why impact missions hold significant value. Our Chandrayaan-1 mission, for instance, was classified as an impact mission. The segment that separates from the spacecraft and crash lands on the moon is referred to as the Moon Impact Probe. Chandrayaan-1's Moon Impact Probe was equipped with an instrument known as Chandra's Altitudinal Composition Explorer, or simply CHASE. It functioned as a mass spectrometer, continuously recording data at 4-second intervals during its descent towards the lunar surface. Thanks to this instrument, we were able to confirm the presence of water in the moon's atmosphere. The Moon Impact Probe's crash site was the Shackleton crater, with the point of impact being named Jawahar Point. Chandrayaan-1 also featured an orbiter, which carried out its orbiter mission independently. Naturally, the Moon Impact Probe requires the support of an orbiter for deployment. NASA's instrument, the Moon Mineralogy Mapper M3, was integrated into this orbiter. When the Moon Impact Probe executed its crash landing, it stirred up some lunar soil. The Moon Mineralogy Mapper M3 was responsible for analyzing this lunar soil, ultimately confirming the existence of water in the Moon's soil. Before going further, I want to share that we provide graphic designing, video editing, and other digital services, so contact us on codemelding.com if you are interested. The link is given in the description. After opening the website, you will find a WhatsApp button you can contact on WhatsApp. Okay, now let's get back to the video. Moving on to the fourth category of moon missions, we have the lander missions. In this scenario, a section of the spacecraft is dispatched to the moon with the aim of achieving a soft landing, devoid of any crashing. The objective is a gentle and controlled landing that enables the designated spacecraft part to safely reach the lunar surface. Executing such a task is exceedingly intricate. During the initial attempts by the United States and the Soviet Union, they faced failures in their initial 15 attempts. The breakthrough came in 1966, when the Soviet Union once again succeeded in achieving the first soft landing in their Luna 9 mission. This marked the world's inaugural successful lunar landing, accomplished by a spacecraft that also captured the moon's surface in its first ever photograph. Here's an image of that photograph. Do keep in mind that this photo may not exhibit exceptionally high quality since it dates back to 1966. Typically, lunar landers are quite substantial, both in size and weight. Consequently, once they touch down on the moon, they remain stationary and do not traverse the lunar surface. However, if mobility on the moon is desired, there exists a solution: rover missions. Rovers are compact robotic devices equipped with wheels that enable them to disembark from the lander and explore the lunar terrain. Rovers facilitate direct interaction with the moon's surface. The initial successful rover mission was executed in November 1970, and it might not come as a surprise that the country behind it was once again the Soviet Union. Lastly, we come to the final category of moon missions: human missions. In these missions, astronauts are placed within landers, which are then carefully guided to the moon's surface. Instead of rovers, these missions rely on astronauts using their own feet to step onto the lunar surface. The United States accomplished this before the Soviet Union in 1969, when Neil Armstrong became the first human to set foot on the moon. NASA conducted the last human moon mission in 1972, and since then, no one has ventured to the lunar surface. In total, only 12 individuals have had the privilege of walking on the moon, and they were all from NASA. You might be wondering why the first rover mission followed the first human mission. The rationale behind this lies in the fact that a soft landing sufficed for a human mission. However, for a rover mission, it necessitated the development of new technology to create a functioning rover. This significant achievement occurred just 1 year after Neil Armstrong's historic first steps on the moon. The Chandrayaan-3 mission had been meticulously planned as a rover mission. According to the mission's original blueprint, the Vikram lander was destined for a gentle touchdown on the lunar surface, carrying within it a rover named Pragyan, which would have embarked on a lunar exploration. However, regrettably, this meticulously planned mission did not unfold as intended. On September 6, 2019, as the Chandrayaan-2's Vikram lander was preparing for its soft lunar landing, an unexpected event transpired. It crash-landed on the moon's surface. Subsequent investigation, as detailed in the Failure Committee report released in November 2019, attributed this unfortunate outcome to a software glitch. What was rather surprising was that ISRO did not make this report publicly available. This departure from ISRO's tradition of transparency drew criticism, as the organization had previously been forthright in sharing its successes and setbacks with the public. For several months following the incident, ISRO maintained that the lander was still intact and had not suffered any damage, contending that it was merely lying tilted on the lunar surface. However, as public pressure mounted, on January 1, 2020, ISRO's chief acknowledged the truth. The lander had indeed crashed and was irreparably damaged. The data from ISRO's Mission Control Center indicated that Vikram lander deviated from its intended trajectory when it was approximately 2 kilometers above the lunar surface. Tragically, contact with the lander was lost at an altitude of about 335 meters. According to the mission plan, Vikram should have significantly reduced its velocity by the time it reached 400 meters above the surface. Astonishingly, even at a height of 1 kilometer, Vikram's vertical velocity remained at 212 km, with a horizontal velocity of 173 km. ISRO's current chief, S. Somanath, revealed that the issue stemmed from an engine anomaly within Vikram. Out of the 5 engines, one exhibited slightly higher thrust, leading to instability. Vikram was supposed to capture images to pinpoint its precise landing location, but it never achieved the necessary stability to do so. Any attempts to correct its orientation resulted in uncontrollable spinning due to thruster misalignment. Vikram's software had limits on its rotation speed, and these issues compounded, ultimately culminating in the crash landing. This is the extent of our knowledge on the Chandrayaan-2 mission incident. Now let's delve into Chandrayaan-3, which was launched to fulfill the objectives that Chandrayaan-2 couldn't achieve. To mitigate the risk of errors, several modifications have been incorporated. Firstly, the landing area has been significantly enlarged. While Chandrayaan-2 had to land within a 500-meter x 500-meter area, Chandrayaan-3 can choose from a much more expansive 4-kilometer x 2.4-kilometer region, a nearly 40-fold increase in available landing space. Secondly, Vikram lander in Chandrayaan-3 carries a greater quantity of fuel, extending its operational duration above the lunar surface. This extra fuel will facilitate a more thorough search for the optimal landing site. Thirdly, software upgrades have been implemented to enhance Vikram's capability to adjust its rotation speed if necessary. Lastly, Chandrayaan-3 will not solely rely on photographs for the landing process. The Chandrayaan-2 mission is often regarded as partially successful, with its orbiter remaining operational. Remarkably, it continues to orbit the moon to this day. The high-resolution images captured by the Chandrayaan-2 orbiter have been provided to the new Vikram lander, aiding in precise landing site selection. Chandrayaan-3's Vikram lander design closely resembles that of Chandrayaan-2, with a few notable enhancements. The landing legs have been reinforced, additional solar cells have been integrated, and sensor technology has been upgraded. The overarching mission objective, akin to Chandrayaan-2, remains focused on landing at the moon's south pole and deploying a rover. The chosen landing site, situated at 70 degrees south, is characterized by numerous craters, perpetually shrouded in darkness, as sunlight never reaches them. Scientists believe these craters may contain traces of ice. It's worth noting that once the rover is placed on the moon by Chandrayaan-3, it will have only 1 lunar day to conduct its scientific experiments. A lunar day is equivalent to about 1 Earth month, comprising roughly 2 weeks of daylight and 2 weeks of night. Consequently, the expected landing window on the moon falls around the 23rd and 24th of August, allowing the rover a mere 14 days to collect data. The instruments aboard Chandrayaan-3 are not equipped to endure lunar nights, during which temperatures can plummet to 232 degrees. In such extreme cold, none of the instruments would function. Hence, ISRO aims for the landing to coincide with the moon's sunrise, providing 14-15 working days. If the landing cannot be accomplished in late August, they will wait another month and target a landing in September. In terms of specifications, the Vikram lander weighs 1,750 kilo, while the rover Pragyan weighs 26 kilo. The Chandrayaan-3 mission comprises 3 modules: the lander module, the rover module, and the propulsion module. The lander and rover modules have well-defined purposes. The propulsion module's role is to propel Chandrayaan out of Earth's orbit and direct it toward the moon. This module will assist in achieving lunar orbit, and when they approach within a 100-kilometer radius of the moon's surface, the lander and rover will be released for landing. Notably, there is no orbiter module in this mission, as Chandrayaan-2's orbiter is still operational and will be utilized. The propulsion module will continue to orbit the Moon for 3 to 6 months, serving communication and data collection functions. It is equipped with an instrument called spectropolarimetry of habitable planet Earth, abbreviated as SHAPE, designed to search for small exoplanets in space. If we delve into the instruments on the Vikram lander and Pragyan rover, they are indeed intriguing. Pragyan is equipped with 2 instruments, LIBS, which stands for Laser-Induced Breakdown Spectroscope, and APXS, denoting Alpha Particle X-ray Spectrometer. LIBS will be employed to analyze the chemical composition of the Moon's soil, determining the minerals present. APXS, on the other hand, will perform a similar analysis, but this time on lunar rocks. While Pragyan carries out these experiments, the Vikram lander will be capturing images, which we can anticipate seeing shortly, provided everything goes according to plan. And I am optimistic that it will. The Vikram lander boasts 4 instruments. 1. RAMBA, which stands for Radio Anatomy of Moon-Bound Hypersensitive Ionosphere and Atmosphere. It will endeavor to melt small lunar stones using a laser beam and subsequently analyze the released gases. 2. CHASTE, or Chandra's Surface Thermophysical Experiment, will measure thermal properties, specifically the temperature at the Moon's south pole. 3. ILSA, short for the Instrument for Lunar Seismic Activity, will monitor lunar seismic activity, commonly referred to as moonquakes. This data will contribute to our understanding of the Moon's crust and mantle structure. 4. From NASA, there's the LRA, or Laser Retroreflector Array, which will employ lasers to bounce signals back to Earth. This technology will enable scientists to precisely calculate the landing site of the Vikram lander and the Moon's range. This is facilitated by the presence of 5 other retroreflectors on the Moon. Collectively, with the instruments on the propulsion module, Chandrayaan-3 carries a total of 7 instruments, often referred to as payloads, for its scientific experiments. Beyond the scientific significance, there's a deep sense of national pride associated with this mission. A successful landing by Chandrayaan-3 would mark a monumental achievement for India, making it the 4th country, following the Soviet Union, the United States, and China, to execute a soft landing on the Moon. This milestone was originally anticipated in 2019 had the Chandrayaan-2 mission not encountered setbacks. It's worth noting that India's Chandrayaan-1 impact mission placed it as the 5th country to touch the Moon's surface, following the Soviet Union, the United States, Japan, and the European Space Agency. Since then, 4 additional countries have joined this elite group: China in 2009, Israel in 2019, Luxembourg in March 2022, and the United Arab Emirates in December 2022. Looking ahead, India's Indian Space Agency has its sights set on Gaganyaan, a spacecraft designed to transport Indian astronauts into orbit. Originally scheduled for 2022, this mission has faced several delays and is now expected to occur in 2025. Regarding moon missions on the global scale, Russia's Luna 25 mission was recently launched, but regrettably, it has encountered a mishap and crashed on the Moon. In the United States, Artemis II is slated for November 2024, aiming to send humans into lunar orbit. These astronauts will embark on one of the farthest journeys into space. In the coming years, China is also planning to send its astronauts to the Moon. If you enjoyed this video and have an interest in space, feel free to explore our channel for more space-related content. Thank you for watching the entire video, and please consider subscribing if you find it worthwhile.